Magandang araw! So, I hope everyone who is watching this video is safe, healthy, and happy. So, today we shall continue our discussion on logic. So, remember the last time we were able to define what logic is. So, we were able to know that logic is an art of differentiating good from bad arguments. We were also able to describe what propositions are, which are mainly used in logic. So, in our discussion today, we shall uh, give emphasis on the use of logic in mathematics. Although we know that in other discipline, it has relevant use, specifically in making circuit designs. Okay, so logic is the foundation for expressing formal proofs in all branches of mathematics. Okay, so mathematical logic is the study of reasoning in mathematics, for we know that mathematical reasoning is deductive. Okay, recall that in language there are four types of sentences. We have the declarative, the interrogative, imperative, and exclamatory. However, for our course, we shall only deal with statements which are declarative. Now, we call them propositions. Again, recall that propositions are statements whose falseness or truthness can be determined. So, if a statement is either true or false, then it is called a proposition. Now, statements can also be classified as simple statements or compound statements. I have here four examples, so let us determine if it is a proposition or not. So, Ross is a Filipino is a declarative statement, and we can determine if it's true or false. Then, Ross is a Filipino is a proposition. Close the door obviously is not a declarative sentence, so it is not a proposition. It is imperative, in fact. The third, is it raining, is not a declarative, it is interrogative, therefore it is not a proposition also. The last one, n plus 4 equals 5, is also not a proposition because we cannot determine if it is true or false. We can only determine the truthness or falseness of the statement if we have the value for n. Let us say n is 1, then that equation is true, and otherwise, other values, values other than 1 will make the statement false. Anyway, in both cases, assigning values for n would allow us to determine if the equation is true or false. So, as it is, n plus 4 equals 5 is not a proposition. Now, a proposition can be represented by any variable or lowercase letter such as P, Q, R. So we have here several examples. Today is Tuesday can be represented by small p. It is raining by Q, and I am wearing my sandals by R rather. So compound statements are simply simple statements which are connected, using logical connectives. So compound statements are constructed by the application of logical connectives. So for example, your bicycle is sleek and I love its color. So the word "and" is a logical connective. Another example, today is Tuesday or it is raining, is also a compound statement combining the simple statements today is Tuesday and it is raining using the logical connective or. So we have here a table of logical connectives. Okay, so number one, which is a negation, is not actually a compound statement. So we just use the symbol tilde, or sometimes called squiggly or twiddle, so to denote it is a negation. So recall our statement or proposition, today is Tuesday, so we represented that by small p. So we can negate that by saying today is not Tuesday, or it is not true that today is Tuesday, and then we affix the tilde to our p. So we now have a not p, which is a negation. And then we have a conjunction p and q. So the logical connective and, so we combine the simple statements today is Tuesday and it is raining. So we have the conjunction statement today is Tuesday and it is raining. So we use the symbol hat, okay, for conjunction. The third connective is or the second connective rather, the second connective is or, which can be used for disjunction. So we see this example, it is raining or I am wearing sandals. So the symbol used for conjunction is the small letter V. So we have Q or R to symbolize the statement which is a disjunction. It is raining or I am wearing sandals. The third logical connective is if-then, which is an implication or a conditional. So, medyo natakpan ko. So, it is conditional or implication. So, we have Q implies R. So, we see the words if-then. So, if it is raining, then I am wearing my sandals. So, we have if-then. So, if it is raining, then I am wearing my sandals. So we have Q implies R, which is a conditional or an implication. And then the last one is we have if and only if, which is a biconditional. So we have a conjunction when we see and, a disjunction when we see or, an implication or a conditional or a conditional rather when we see if then, and a biconditional when we see if and only if. Like in this example, I am wearing my sandals if and only if it is raining. So the symbol for a biconditional is a double-headed arrow, where a single arrow is used to denote for a bicondition or for a conditional rather or an implication. So again, we use and for a conjunction symbolized by hat. We use or for disjunction symbolized by small letter V. We use one-headed arrow to symbolize a conditional statement or an implication, that is an if-then statement. And then we use a double-headed arrow to signify a biconditional compound statement where we see if and only if. Okay, so we proceed to the discussion of truth value. As we mentioned earlier, a simple statement is one which is either true or false. Now, the truth value of a compound statement, where we use connectives, depends on the truth value of the simple statements which compose the compound statement and the connectives used, the logical connectives. So, so let's discuss first negation. So the negation of a proposition is like identifying its complement. So we see the words not. It is not the case that, no, never, none, nowhere, and no, and all of these mean a negation. So for example, our P is today is Tuesday, and therefore our not P, which is a negation, is today is not Tuesday, or we can also say it is false that today is Tuesday. And then we have the truth value for the negation. So we only have one variable P, such that if P is true, not P is false, and if P is false, not P is true. So it's just the complement. The truth value of not P or the negation of P is the opposite of the truth value of P. So madali lang naman siyang matandaan. So to proceed, we have the conjunction where we use the logical connective and. So these words signify a conjunction: but, still, while, yet, whereas, despite, although, nonetheless, nevertheless, moreover, in spite of, furthermore. All of these refer to a conjunction. So they can replace the word and to mean a conjunction. So for the truth value, notice that, okay, so if P is true and Q is true, P and Q is also true. And if one of the conjuncts is false, the conjunction is now false. So madali ring matandaan, pag may isang false, false na yung conjunction. So dapat kasi pareho silang tama, pareho silang true for the conjunction to be true. Okay, so if we use the binary representation, 1 for true, 0 for false, so you notice that the conjunction will only be 1 if both P and Q are 1. Otherwise, P and Q is 0 or false. No, the truth value is false for the conjunction. Then we have the disjunction. So we use the logical connective or, which is represented by the small letter V. So we see words like else, either, unless to refer to a disjunction. So all these may replace or to mean a disjunction. Okay, so for the truth value, you notice that the truth value of the disjunction will be true if one of the disjuncts is true. So, kanina yung conjunction, pag may isang false, yung conjunction false na. Sa disjunction, pag may isang true, true na yung disjunction. Okay? So, again, if we use the binary representation, if one of the disjuncts is true, if one is true, then the disjunction is true. Okay? So, ito lang ang false kasi parehong false yung disjuncts. And then we have conditional, which uses if-then, no? So, we read this as Q implies R, okay? Now, Q, or the proposition if, is called the premise or the antecedent, while the proposition R with then statement is called the conclusion or the consequence. So, if is the premise or the antecedent, and then is the conclusion or the consequence. Alright? So, these are the words which can be used to mean a conditional. So, if P then Q, P implies Q, P is a sufficient condition for Q, P only if Q, Q is a necessary condition for P, Q if P, Q follows from P, Q provided P, Q whenever P, Q is a logical consequence of P. So, observe kahit ganito siya, it also means P implies Q. So, dapat pag-construct natin, P implies Q pa din. Okay, so for the conditional truth table, notice that the implication or the conditional will only be false if we have a true antecedent and a false consequent or conclusion. Okay, so all other combinations will give a true conditional. Okay, so again, false lang ang conditional kung yung antecedent ay true at yung conclusion, yung antecedent or premise, no? Yung antecedent or premise ay true, tapos yung conclusion or consequent ay false, yun lang ang false na conditional. All other combinations will give us a true conditional. So again, if we use a binary representation, we will have this. So, 0 lang siya kung true yung P at false yung Q. So, for the related conditional, so we have 3 related conditionals. So, remember, we have the conditional P implies Q. If it is raining, then I am wearing my sandals. And then we have the inverse. Lagyan mo lang ng negation yung P at saka Q. So, if it is not raining, then I am not wearing my sandals. Then we have the converse. You will, you will exchange, no, Q and P, the order of Q. So, Q now is the antecedent and P is the consequent, no? So, pagbabalik-tarin mo lang, yun yung converse. So, we say, if I am wearing my sandals, then it is raining. And then, contrapositive, yun naman converse, lagyan mo ng not pareho. Such that, we say, if I'm not wearing my sandals, then it is not raining. So, those are the 4 related conditionals. So, we have conditional, inverse, converse, and then contrapositive. So, here's the truth value for the inverse truth table. So, you just affix the negation, no, of both P and Q, and then get the conditional not P implies not Q. So, notice that the inverse will be false if you have a true not P and a false not Q. And then the converse, so you have Q implies P, will only be false, no, if Q is true but P is false. All the rest will yield a true converse statement. And then the last one, contrapositive, not Q implies not P. The same rule applies. The contrapositive will be false if not Q is true and not P is false. All other combinations will yield a true contrapositive. So, if we compare the values, we notice that the conditional, the conditional statement and the converse, so the first and the third column, have the same truth values. whereas the inverse and the contrapositive, so the one written in red, are equivalent. They have the same truth values. What does this tell us? So in any argument, a converse statement can replace a conditional and vice versa. Also, in any argument, an inverse can be replaced by a contrapositive statement and vice versa. It will not affect the truth values. So for the last connective, the biconditional, so we use if and only if. So we see the words provided that and only provided that, when and only when to mean a biconditional. So those phrases can replace if and only if. So what is the truth table for a biconditional? Notice that the biconditional P if and only if Q is true if the truth values of P and Q are the same. So if P and Q are both true, you have a true biconditional. If P and Q, so for the last row, if P and Q are both false, then the biconditional is also true. So para maging true yung biconditional, dapat pareho ng truth value yung P and Q. Otherwise, false siya. So if we use the binary representation, we have this. Okay, so going on to the three classes of compound statements. So we have tautology, where the truth values on the last entry is all true. So you look at the third column. So the truth value is true for the first row, also true for the second row. So all truth values for this statement are true. And therefore, we say that this is a tautology. The next one is an absurdity, where this time all the truth values of the last entry are false. Okay, so notice that the last column, all rows of the last column have false truth value. So that's an absurdity. And then the last one is a contingency, where it is neither a tautology nor absurdity. So parehong may true, parehong may false. Okay, so let us try to find truth value of complex statements. So here, for example, we are given that P is true, Q is true, and R is false. So for example, we have the quantity P or Q and R. So how do we solve truth value of complex statements? So we must be familiar with the rules. Ano na nga yung rules? I-recall natin. Pag conjunction, pag may isang false, false ang conjunction. Ang disjunction, pag may isang true, true ang disjunction. Ang conditional, if then, false lang siya pag true yung antecedent, tapos false yung consequence. So, TF, dun lang siya magiging false. Otherwise, all combinations will be true. And then, for biconditional, true siya kung pareho ng truth values yung dalawang propositions. So, tingnan natin. Okay? Ito ay this is primarily a conditional, conjunction rather. For the rule, if one of the conjuncts is false, then the conjunction is false. Notice that R is false. R is false here. So no matter what the value of P and Q are, and the disjunction P or Q, it does not matter because one of the conjuncts is false. Therefore, this is already false. Next, we have P and P implies R. So the same argument, this is a conjunction. So if one of the conjuncts is false, then the conjunction is false. It is given that P is true. So we should determine the truth value of P implies R. So P is true, R is false. Therefore, the conditional P implies R is false. And therefore, we have true and false. Therefore, this is a false complex statement. And then for the last one, we have P if and only if Q or R. So, ano na nga yung sa disjunction? Pag may isang true, true na siya. Okay? Yung R natin, false. So, dapat ma-determine natin yung P if and only if Q. P is true, Q is true. Therefore, they have the same truth value and therefore, the biconditional is true. Since one of the disjuncts is true, the disjunction is true. Okay? So that ends our lecture today. So next is your activity. So you have to determine the type of proposition. Okay, uh, is the statement a proposition or not? And then you will determine if the statements are tautology, absurdity, or contingency. And the last one, you will determine the truth value, no, given that P is true, Q is false, and R is true.